Hello, ladies and gentlemen, Mr. Miller here for your Algebra 2.4 notes, solving multiple step inequalities here. So the main things that we'll be able to do after these notes are hopefully to solve multiple step inequalities. Also, we will use multi-step inequalities to solve real-life problems. So two main things here: solving multi-step inequalities and using that to solve some real-life problems. So as usual, we got some warm-ups here. Hopefully you're doing these warm-ups on your own. Hopefully you're taking care of those before the video. But if not, following along as we do here. So it asks if 4 is a solution of the inequality. So simply they want you to know, let's plug in that 4 into the A and see if it is an actual solution to the inequality here. So plug it in. 2 times 4 minus 1.5. Is that greater than or equal to 6? Cleaning it up, 2 times 4 is 8, minus 1.5. That has to be greater than or equal to 6. And cleaning it up one more step, 6.5 is greater than or equal to 6. Is that a true statement? So again, this is kind of our check work here, ladies and gentlemen, that we do or have been doing, plugging in an answer. So is this answer, which we might have gotten from the number line, is it correct for our inequality? And in this case, 6.5 is larger than or equal to 6. So yes, 4 is a solution. Second one here, solving our equation for f. So I'm going to use their work and go off from that. So we need to subtract 8 first. So again, we get f over 4 is going to come out to equal a minus 1. It's being divided by, so again, we're trying to get f by itself. So we're multiplied by 4, multiplied by 4, and f comes out to a minus 4. Again, we want to check our work, ladies and gentlemen. So we're going to check it by plugging in that answer. So minus 4 is what I think the f is. Over 4 plus 8, does that come out to equal 7? Minus 4 over 4 is a minus 1, plus 8, does that equal 7? And yes, 7 equals 7. So minus 4 for my f was 100% correct there. Story problem time now here. So again, these could be inequalities or they could just be an equation that we're setting up. So you got to read through them carefully and look for those key words for either a greater than or less than or greater equal to in there as well. Or maybe it's just equal to. All hats sell for the same price. All right. So if I'm looking at a hat, they're all the same. So I'm going to let my hats be my X's. You buy one pair of sunglasses for $7 and 2 hats. No price on the hats, but we do know they are the same price. So that's why we represent them as the X. You spend $26.50. So this is an equal sign. We are spending this. We're not spending more. We're not spending less. We're spending that. How much did each hat cost? Well, if we have 2 hats that we don't know the price of them, we'll represent that as we have 2 hats. We don't know the price. We have already spent $7 towards that price, and the grand total is $26.50. So we actually have an equation here that is equal on both sides. and then we go through and start solving. So minus 7 from both sides. So we get 2x equals 19.5 or 1950. And then divide by 2 on both sides. And we get an x that comes out to an answer of, it's going to be 975. So again, check your algebra work by plugging that back in there, ladies and gentlemen. Just to make sure you didn't make any mistakes. Again, you do have to set up the equation correctly. So if you don't set that up correctly, you're just checking your algebra work here. All right, does not check to make sure that you've set it up, or could actually give you a red flag if you're thinking hats come out to, $30. Well, you only spent $26.50, so that can tell you, oh, I need to go back and do some adjustment here with my equation that I set up. So again, just plugging it back into your equation, 2 times that 975 plus 7 has to come out to 26. That does come out to 1950 plus 7, which 26 is 26. So our hats do cost us $9.75 each. So the hat is equal to $9.75. All right, into the brand new ones here. So solve inequality, graph your solution. So this is multiple step 1. So very similar to what we left off from yesterday, or at least from the 2.3 notes. Again, treat this like an equal sign. So what would we do if this was just an equal sign? How do we solve for x? We have to get rid of x, get it all by itself. So what's attached to it is a minus 5. So to undo that minus 5, we add 5 to both sides. Clean it up. 2x is less than or equal to 28. Again, we want x all by itself. So we're going to divide by 2. We aren't dividing by a negative, so the sign does not switch. All right, so the sign stays the same. So we are going to have x is less than or equal to 14. Here's where we check it on our number line. So as always, have 0. I like to have the 14 and the negative 14 on my number line. And again, if you have your variable first, that tells you which way your arrowhead is going. Again, an equal sign means shade that circle in above the 14, and then our arrow should be pointing to the left. How do we check it? Pick an easy answer. I always like, if a 0 is a part of my answers, I'm going to use that because there's usually less thinking to do. So we're going to check with our x equaling 0. So we'll plug that back in. 2 times 0 minus 5 has to be less than or equal to 23. Then we get minus 5 is less than or equal to 23. Is that a correct statement? If that is a correct statement, your answer was done correctly. If you get an incorrect statement, then you made a mistake in your algebra work, or you made a mistake in switching the signs when you weren't supposed to switch the signs. So we got to go back and figure out, okay, where should the correct answers be if 0 was not a correct one. Next one, we'll do this one together. So again, solving for y, we have a minus 5 to both sides to start. So you get minus 6y has to be less than or equal to a minus, looks like 21. We gotta get y by itself, so we have to divide by a negative 6. Hint, hint. Oh, we're dividing by a negative or multiplying by negative. Remember, we have to switch the sign. So y has to be greater than or equal to, it's a negative over negative, and it sort of cleans up to 21 over 6, which I'm also going to write as y is greater than or equal to 6 goes into there 3 times. That's 18. And then I have 3 6 left, so that's actually 3.5. So down to my number line, 0, 3.5, minus 3.5. Again, there's an equal sign to this, so I know above the 3.5 it's going to be shaded in. And then again, as long as your y is on the left side, ladies and gentlemen, this tells you which way the arrow's to go. So my arrow goes off to the right. So I think all the answers are going to be greater than 3.5. So if we've done this correctly, when we check, I'm just going to do the next one. We'll say we do 4, because 4 is bigger than this. That's the next number that's there. Plugging this in, we get minus 6 times 4 plus 5 more has to be less than or equal to a minus 16. This is going to be a minus 24 plus 5 less than or equal to minus 16. And then cleaning that up, that gives us minus 19, and that is less than or equal to minus 16. Again, meaning that it's on the left side, further left, smaller, so your numbers get bigger and bigger and bigger as you go negatively, ladies and gentlemen. So that is a correct statement. So your y is greater than or equal to 3.5 is correct there. On the back side, we'll go through these together. Looks like actually all of these we will go together, go through together today, just because they're all a little bit different here. Again, 2 ways to start this. I personally do not like fractions. So if there's nothing that's being added or subtracted to these parentheses that I need to clean up beforehand, I like to get rid of the fraction. If you want to distribute that half through, feel free to distribute that half through. But I like to get rid of distribute the 1/4 through. I like to get rid of that 1/4. So it's being divided by 4. So I'm going to multiply, and at the same time there's a minus sign here. So I'm going to get rid of that minus as well. So I'm going to multiply by 4 on the left, and I'm going to multiply by that minus 4 on the right. So my fraction disappears, and I'm left with p minus 12. We multiplied by a negative, so the sign has to switch. So it has to switch, and then I get a positive 8 on the right. Still trying to get p by itself, so we're going to add 12 to both sides, and p is going to be less than 20. So 0, 20, minus 20. No equal sign this time, so we have our open circle, and then again my variable is first, so I know the arrow is pointing me in the right direction. Again, we want to check this, and look, notice 0 is another nice one that's in here. So we'll go ahead and check that with a 0. So when I check this, I'm making my p equals 0, and I plug it back into the original. So minus 1/4, 0 minus 12 has to be greater than minus 2. So here we just get 12, and that is a negative, and I'm dividing it by a negative 4, if you will, or dividing it by 4 and then multiplying it by a minus 1. So 12 divided by 4 is 3, which is negative, and then from there we got to multiply by negative 1. So this all cleans up to 3, and is 3 larger than minus 2? And the answer is yes, it is. That is a true statement. Next, again, goal is always to get x's on one side and then by itself, numbers on the other side. So you can move this any which way you like. I personally like to get rid of the smaller ones. So move the smaller ones first for my x's. So I'm left with a positive x. If you move the -9, then you're going to have to deal with a negative there. So less switching, the better. So I'm going to move the -6. So I'm going to subtract that from the right side and the left side. At the same time, ladies and gentlemen, not trying to confuse you, but we're going to move this 6 over also next. So sometimes I like to show this in my work right now, which that's a +6. So I'm going to subtract 6 and subtract 6. Haven't been doing my lines too much, but we have got a lot going on here. So 9x minus 6x is 3x. 6's cancel, so they're gone. Less than or equal to. 6x's are gone. And then we have 21 minus our 6, which is 15. Divide by 3. Again, this is not a negative number that we're dividing or multiplying by, so the sign stays the same. So x is going to be less than or equal to 5. So on our graph, put the plus and -5 down. It is an equal to sign, so it will be shaded in. And then as long as your variable is on the left, arrowhead tells you which direction. So again, 0 just happens to be one of my answers. So again, I'm going to use that one. So we're going to let our x equal 0. So we get 9 times 0 plus 6 has to be less than or equal to 6 times 0 plus 21. Now that's going to come out to be 6 is less than or equal to 21, which tells me my answer is 100% correct. Our next set here, ladies and gentlemen, we're going to solve the inequality if possible. So we're going to see a situation like we saw before when we were solving using equals. You're going to get either one solution, no solution, or many solutions here. So let's start attacking them. So this one, very similar to what we just did here. So we have, I like to move the smaller x first. So -3x, -3x. At the same time, I know I need to add the 12. So I'm going to add the 12 also. So we get 2x. We can clean it up. Is going to be less than or equal to, we're going to get a +8. Again, divide by 2. And x comes out to being less than or equal to 4. And the sign did not change because we had no negatives. So from there, we graph it out. We get 4 and -4 and 0. Above 4 is a solid. Again, my variable's on the left, so the arrows actually help me. And we check it. So again, I'm going to use that 0 again. So I'm going to check with x equaling 0. So 5 times 0 minus 12 has to be less than or equal to 3 times 0 minus 4. Again, just plugging it back into the original there. And then cleaning it up. So again, -12 is less than or equal to -4. And that is correct. -12 is further this direction than what -4 is. So -4 is greater than -12. So we are good to go there. So that's just like a normal one. There's one solution there. We can graph it out. So let's see what happens with these next two. They will be different. So on this one here, considering you got more stuff on the right side, it isn't just a single thing. I would just go ahead and distribute through the 5 here. I wouldn't divide by 5, because if you divide by 5 on this side, then you got to divide by 5 on that side, and you start to get, if you look forward, 17 doesn't go into 5 nicely. So that's why I would not get rid of the multiplication of 5. So distribute. So we will distribute. So this comes out to 5m plus 25 has to be less than 5m plus 17. I have to subtract my 5m. And I'm doing this in one step because I'm starting to see something here. If I subtract 5m and I subtract 5m, both my 5m's cancel out, leaving me 25 is less than 17. That is a false statement. And usually put like a slash through this. So 25 is not less than 17. So there is not going to be a solution. So no solution, which means you'll not have a graph. So this one you cannot solve. And that's what you'd leave it as. 25, that's a false statement. So there's your final answer. So anytime you get a false statement like that, ladies and gentlemen, no solution. And you should be comparing numbers with numbers. For the last one here, again, I'm going to go ahead and distribute here because I'm not going to want to divide by 4 because the other side doesn't divide by 4 nicely. So we'll just keep it nice. So we got 1 minus 8s. That's less than or equal to a negative 8s plus 4. Remember, it is a negative 4 times a negative 1, so that turns it into a positive 4. Then, I like to move my s's, and I'm starting to see something here again. So we're adding 8s to the right side, and we're adding 8s to the left side. Cancels, cancels, so we have 1 is less than or equal to 4. That is a true statement. So if we get a true statement, you're going to get many solutions. So on your number line, we can graph this out. Just pick a number, whatever number you want to pick. Let's say I'll pick 20. And your graph will look like this. No circles this time, just a solid line arrow because every single answer works. So if you're looking at that and you're wondering, well, if I could just plug anything in, yes. When you plug anything in, what we get here is with that 8s on both sides, that's negative, or if it was a positive 8s on both sides when we canceled it out and we get a true statement, any number you put in there, whether it's 0, 100, minus 2,000, you're always going to get this one is 1 more than that answer, and this one's 4 more than that answer. So this one always becomes, at least 3 times bigger every single time, no matter what number you put in for S. So we get many solutions there because we get a true inequality. Last one, story problem here. So you can work at most. All right, so that means we can work at most, so no more than 24 hours. So we can work the 24 hours, so that's going to be an equal to underneath that. And just depending on which way you set it up, which way you want to go with this. Let's read a little further though. 24 hours per week as a nurse aide. So far this week you have worked 7 hours. The remaining shifts of the week are each 4 hours long. How many possible full shifts can you work? All right, so shifts are what we're looking for. So those are the things that we're looking for as wholes. So we'll let that equal X. And we're 4 hours long. All right, so ultimately we're wanting to know how many possible. So we'll get to that in a second. We need to set up our inequality first. So I'm going to put the 24 on the right side. So at most 24. So that's as high as we can go for the week, 24 hours. Give me equal to that. So far this week we're 7. So I'm going to add that in, plus 7. And then we have 4-hour shifts, and we don't know how many we can fit in here. So that will be represented as our 4x. And again, we jump into subtracting our 7. So 4x has to be less than or equal to 17. Divide by 4 next. So x, leave your sign the same, is going to be 17 fourths, which we'll just go ahead and change that to a mixed number. So that is 4 and 1/4, because it goes into 4 times 4 is 16. So 4 and 1/4. So they want to know how many possible full shifts. This would be the answer if we didn't want to know the full shifts, just how much more they could work that week. But in this one, they want to know full shifts, so it has to be a whole number answer. So here, the first whole number that is less than or equal to 4 1/4 is 4 shifts. So she can work 4 shifts that are full. And that is our final answer there. And if you want to do a number line, you can do a number line. Thank you, ladies and gentlemen. Until next time.